Hi everyone, today we're looking at problems in real-world contexts, or PRWC for short. It's basically an O-level type of question, usually at the end of a paper, that we give you a problem in the real world and you have to use math to solve these very real problems. And so let's just jump right in to get clearer. Here's an example of what it might look like. A contractor wants to do tiling works on the inner walls of a room. Okay, the tiles are to go up to a height of 1.2 meters. So we look, the dimensions of the room are shown below. So we see over here, yep, there's a room, looks like a room. And 1.2 meters, the tiles are to go up by 1.2 meters, so that makes sense. And then you can see, oh yeah, okay, the walls and the floor dimensions. And over here we see, oh, that looks like a door. And do we need to put tiles on the door? Then we look at the right. This looks like the floor. 3.55 meters, 3.55 meters, 2.5 meters, 2.5 meters. It's the floor. They don't tell us this, but it's the same. This is a rectangle, 3.55 meters. Over here, 0.3 meters. There's a blank. That means the door doesn't require any tiles. And then over here, 1.3 meters, 1.3 meters. So let's try to analyze, really. First off, we have one side of the wall, which is, let's say, this side, right? And that side actually corresponds to this side, right? This part of the floor. And then we have another side, which is the opposite side, and it corresponds to this one. And then we can see that over here, we have another side of the wall we need to cover, and that corresponds to this side. And then we have this side of the wall to cover, the one with the 1.3. Length, and that is this side. And then finally we have this side of the wall to cover this little bit here, right, for the 0.3, and that is this side. Okay, I think it's starting to look a bit more reasonable, start to make a bit more sense. Find the total area of the walls to be tiled. Okay, so right now let's just see total area. So let's break it down and step by step. Let's look at the red one first. So let's look, what's the area of the red part that I've color coded? This is basically 2.5 multiplied by 1.2. 2.5 multiplied by 1.2. And then how about the blue one? The blue one is 3.55 multiplied by 1.2, right? 1.2 multiplied by 3.55, so it's 1.2 multiplied by 3.55, but we have two sides of it. This is also 1.2 multiplied by 3.55, so let's just multiply that by 2. And then we have the pink side, this side, so we have 1.3 over here, 1.3 multiplied by 1.2, so 1.3 multiplied by 1.2. And then we have finally this side, which is 0.3 multiplied by 1.2. 0.3 multiplied by 1.2. Yep. Okay, so we can see that these are all the separate areas, and what we have to do is simply the total area is we add all of them up. Once you add the total area up, you will see that this gives you 13.44 meters square. And there you have it, the total area of the walls to be tiled. Part B, it says one bag of cement can be used to tile 7.5 square meters. Square meters really is, think of it, meter square. And it says calculate the number of bags of cement required. So let's see, let's say one bag can basically tile 7.5 square meters. But I want to know the number of bags for how many? Well, I calculated over here, the total area is 13.44 meters square. So once again, it's like a ratio. What do? We want to find 13.44, but from 7.5, how do I get there? Let's find 1 meter square first. We divide by 7.5 to get 1. So on this side, we also divide by 7.5 to get, let me just leave it like this. All right, from 1, I multiply by 13.44. So from here, I multiply by 13.44. Yep, so really the number of bags is 1.75 from here, and then I multiply it by 13.44, and that gives me 1.792 bags. Of course, I want to round up to give me 2 bags, because if I round to 1 bag, I still have 0.792 that I still need. So I round up, so I have 2 bags. I'll have a bit left over, but that's okay. It clears. It allows me to clear the whole area of all the walls. So there we go, part A and part B. Finally, we have this part C, and PRWC questions are usually like this. The last part uses part A and part B, and it's a giant part. You see, it's actually 6 marks. And it's just really asking you to think and calculate using math to solve the problem. So in this case, the tiles chosen by the contractor has a length 30 cm and a height of 20 cm. Okay, so really, I think I should draw it out. Usually I'll just do this. It's just clearer for me, 30 cm and height 20 cm. And I see that everything so far has been done in meters. So I'm just going to convert this to 0.3 meters and 0.2 meters. Now I'm given the following data for the contractor to calculate the cost. The cost of cement, okay, $20 per bag, sure. Cost of tiles, okay. And the labor cost, $50 per square meter. And then the contractor charges the client $3,000 for the job, and we need to find out, justify with calculations, if he made any profit from the tiling works. Profit means from all the cost, did he charge more than the cost? If he charged more than the cost, then he actually made some money, he made some profit. So we're trying to find out, did he charge more than all the costs? So we need to calculate the cost. So let's look. The cost of cement, $20 per bag. And did we calculate how much cement he needs already? Yes. 2 bags. So actually, straight up, we can already calculate. $20 per bag. So we have 2 bags. So we multiply by 2. You have $40 for the cement. Number of tiles. Did we calculate number of tiles? Nope. We calculated area and we calculated bags, but not number of tiles. So maybe let's leave that for now. Let's see. Labor cost $50 per square meter. Oh yes, we already calculate how many square meters. 13.44. So let's go back and say that, okay, $50 per square meter. So now we have 13.44 square meters. So that will give me $672 for the labor cost. Now what is really left is to find out the cost of the tiles, and you can see that if you buy 1 to 100 tiles, you pay $10 per piece. For this 101 to 200, you pay less, of course. 201 to 300, you pay even less. So we have to find out first, how many tiles does it require, really, to cover all the area, right? We need to find out how many tiles, and then we see which bracket we lie under, and then we see how much we are charged per tile. So let's start. Let's start with maybe the red one again. I think it's easier. So I have a simple one. So we see that the red one is basically 2.5 by 1.2 meters. I think it's good to just draw it out. So we have 1.2 meters here and 2.5 meters. And each tile is what? It's 0.3 by 0.2 meters. So we need to find out, like when we insert the tile, like over here, this is 0.3 for each tile, and then when we insert like vertically, this is 0.2, right? Because the height is 0.2. This is 0.2 also for the height. So we need to know how many 0.3s can I fit horizontally and how many 0.2s can I fit vertically. So the way to do that is I'll just say, for the horizontal part, I'll say 2.5 meters. I divide by 0.3 to see how many tiles I will end up needing to fit. And this actually gives me 8.33 tiles. And I'm going to round up to say that it gives me 9 tiles horizontally. Why do I round up? Because 8.33 means that basically I can fit 1, 2, 3, 4, 5, 6, 7, 8 tiles, and then the last tile is like, it would jut out here, and I need the 0.33 tile. But of course I cannot just buy 0.33 tiles, so I still need this part though, so I'll just buy 9 tiles, and then later the contractor can just hack this part off and discard it, and we just keep the 0.33 tiles. So yep, so that is horizontally. So now let's do the same for vertically. So maybe let's just write that down. This is for horizontal. And then for vertical, what I can do is take 1.2, divide by 0.2 to see how many tiles I need to cover the whole vertical length or vertical height. So I take 1.2, divide by 0.2, right? 1.2 divided by 0.2. And that gives me 6 tiles. Nice number. So over here, it just means I need 6 tiles to cover this whole height, and I need 9 tiles to cover this whole length. And so the total number of tiles to cover this entire area is basically 9 times 6, which finally gives me 54. Ta-da! That means for this side, I need 54 tiles to cover the whole wall. Then we do the same now for all the other sides of the walls. So let's do the blue one. So for the blue one, we can see that it's 3.55 by 1.2, and so let's just draw it out. 3.55 meters by 1.2 meters. And same thing for horizontal and vertical. So for horizontal, let's say it's 3.55 divided by 0.3. And that gives us 11.83. So I'm just going to round up to 12 tiles. Vertically, we have 1.2 divided by 0.2 also. So actually, it will always give me 6 tiles. So actually, the total number of tiles for the blue side is 12 times 6, which gives me 72 tiles. But of course, if you take a look, it means that for one side, we have 2 sides. So really, we can see it over here, 72 tiles. And on this side, 72 tiles as well. Okay, let's do the pink one now. So for the pink one, we can see that for, that's 1.3 by 1.2. Right, the height is always 1.2. So we have 1.3 by 1.2. Yep. Definitely the diagram could be drawn better. 1.3 by 1.2. Okay, and so we can see, let's divide again. Horizontally, we have 1.3 divided by 0.3, and that actually just gives me 4.33, and so I'm just going to round up and say I need 5 tiles. And vertically, I'm going to say it's 1.2 divided by 0.2 once again, and of course it's 6 tiles. So total number is 5 times 6, which gives me 30 tiles. Great. So over here, I can say that for this section, I need 30 tiles. And now we're left with the yellow side, which is 0.3 times 1.2. And so let's go 0.3 multiplied by 1.2. And so same thing, horizontally, 0.3, how many tiles do I need? Is simply 0.3 divided by 0.3, which is 1. So actually 1 tile will fit exactly nicely. And then vertically, it's still 1.2, so we can say it's a 1.2 divided by, in this case, remember each height of the tile is 0.2 meters, so that gives me 6. That means I can fit 1, 2, 3, 4, 5, 6 tiles, and it will fit that part of the wall perfectly. And so we can say that the total number of tiles for this side is 1 times 6, which is 6 tiles. Yeah. And so we can come here and say it is 6 tiles for this side. And there you have it. You have the total number of tiles that you've calculated for every side of the wall. And so we can see over here that we have 72 tiles for this side, 72 tiles for this side, 54 for this side, 30 here, and 6 over here. And let's just add them all up to find the total number of tiles. So let's go and use some space over here. So we have 54 plus 72 plus 72 plus 30 plus 6. And, is that right? Yes. And then the total number, it gives me 234 tiles. This is for the total number of tiles for all the walls combined. And so now we can see 234, which bracket are we under? We're actually under this bracket. Right, we're actually under this bracket. 234 is here. So we are going to be charged $7.50 per piece. So what's the total cost of tiles? So the cost of the tiles is thus $7.50 per piece multiplied by the number of pieces that we have, which is $1,755. Ta-da! Okay, now let's see how much is the total cost. We have over here $40 from the cement, $672 from the labor cost, and now we have $1,755 from the tiles. And that's it. We've covered all three sources of the cost, and let's add them up. So total cost 40 plus 672 plus 1,755, and this gives me $2,467. And so we want to see, is there a profit? Is there a profit? Yes, because he charged $3,000 for the job, and he made a profit. So we subtract this away, he made a profit of $533. Wow. And so really we can conclude, they say justify with calculations if you made any profit. So we can say he made a profit of $533. Done. And there you go.